All right, so today's talk is really about a trend that you may or may not be seeing in your environment. And it's this trend of architectures now evolving, not over months, over quarters, but release over release, deployment over deployment, sprint over sprint. And so love to talk about what that trend is, as well as what you can start doing to cope with it. So I want this to be interactive. This is the last session before prizes are announced, so I'd rather not be here just talking. So let's try something different. I'd love interaction. Please stop me, ask questions. But maybe we can start with just a quick survey. So part of this talk is about infrastructure as code. And I'd love to understand, who in the audience is familiar with infrastructure as code as a concept. Just show of hands. All right, so a good number. Don't worry, for those of you that aren't familiar, I will give you a very quick primer. For the folks that are familiar with infrastructure as code or are seeing it in their organization, what languages are you seeing? Terraform? Anyone? CloudFormation? All right. Azure Resource Manager templates? Anyone with Pulumi? All right. That's a... and maybe if anyone's open to sharing, what kind of code sizes are you seeing? Okay. I think a lot of the same folks were here for the last talk, but I'll ask the same question, right? Like, how many of you are security professionals? All right, so good number. How about developers? All right, so we got some developers. For the security professionals, are you reviewing the Terraform that's in your environment? How do you get engaged? And okay, yeah, that's a challenge across many organizations that I've worked with. So awesome. So for those of you that are not familiar with infrastructure as code, I'll start off with a quick primer and take us back 10 years in history. So just 10 years ago, most of the companies that I worked with, right, there were two different teams that were involved in shipping software. You had your infrastructure teams and your software development teams. Today, infrastructure is now defined as code in languages like Terraform, CloudFormation, Azure Resource Manager templates. And increasingly, what's happening is this code is now falling under the umbrella of software development teams. So more and more, the ownership and the responsibility for this code is falling under the umbrella of software development teams. We're really seeing this trend where developers are being empowered to take ownership of the entire release management lifecycle and the feedback loop that comes back. And so, you're seeing, these new models within organizations where infrastructure as code is now being developed as part, there's SREs or DevOps folks that are helping write this code, but they're really, supporting that software development effort. And more, that infrastructure as code is being afforded the same best practices that we afford to application code. So today, you can now build infrastructure in an iterative manner. You can deliver infrastructure capabilities in an iterative manner. So as customer requirements change, you can update your architecture to add new capabilities. And I'll just touch a little bit about why companies are adopting infrastructure as code. The biggest reason is to drive more velocity and more agility into their products. It gives you automation to automate the deployment of your application, simplifies infrastructure provisioning, but most importantly, right, it's code. So it's version controlled, it's repeatable, it's scalable, it's consistent. So now you can get consistent deployments. It's much easier to manage at scale. And if you kind of think about the transformational journeys that most organizations that weren't born in the cloud go through, they start with a lift and shift approach. And usually, right, you're lifting and shifting VMs into the cloud, and all you did is change data centers at that point. But then, eventually you realize that it actually costs more to do this, to run their servers in AWS. And so you start really breaking down your monolithic applications, move towards more microservice-based architectures. And as that trend happens, what you see is it's incredibly complex to manage these applications. If you're doing manual provisioning approaches and there's a lot of click ops involved, it doesn't scale. And so that's where you'll see organizations really shift towards infrastructure as code, because it's an automation that allows them to really manage those kind of complex applications. And I didn't quite describe what it is, so for those of you that aren't familiar, it's a declarative language that lets you declare infrastructure and infrastructure architectures as code. So any questions? All right. So what has happened over the last 5 years is now, what we're really seeing is entire application architectures are now codified in languages like Terraform. So if you look at an example Terraform, and I asked the question around lines of code because, an application architecture like this may range anywhere from like 10 to 30,000 lines of code. I work with customers, for example, that have like applications in the cloud that are so complex. There's 70,000 lines of code. They have like 5,000 different components. It's incredible. And part of the reason why this is happening is because once you codify your architecture in code, it's much easier to manage and it's much easier to build more complex application architectures. So you need 500 lambdas? Sure, right? We can just add 500 lambdas to your application architecture. And fundamentally, this is allowing development teams to accelerate faster, right? They're no longer dependent on other factors to really deliver new feature capabilities. If they want to add a machine learning service, they can just go add a machine learning service to their application architecture by changing a few lines of code. And that is fundamentally what's happening, and that is the trend that I want to talk about. So these architectures are changing from release to release, and we see this with our customers. We see, we're plugged into their pipelines, and so we see from release to release how their infrastructure as code is changing. We work with customers that have, where we engaged very early on in the proof of concept phase. And so we have a lot of this data. And what we're seeing is, from release to release, these Terraform files are changing. And fundamentally what that does is it's changing your application architecture. And when I think back to, my career as a security architect, one of the biggest things that frustrates security architects is scope change. You assess a particular application architecture, but then what gets deployed is something completely different. And you find out later on, and now you're playing a game of catch up, and it's the friction that then gets created between the enterprise architects and developers and the security architects that you have to now navigate. And it becomes a 6-month roadmap to design something that's a mitigating design and implement it and then ship it in production. And now that what this has done is exacerbated that problem. Now that's not happening on the time scales of months, it's happening on the time scales of days. And from day to day, things can change in your application architecture that you may not be familiar with. So there was a talk yesterday that Ravi gave on API security. And he has a very good example that personally I've experienced many times over, where someone develops an API, and that API was designed for internal use, and as it evolves, right, it gets exposed to business partners. And if you're not plugged in as a security architect into the lifecycle and you didn't see that change happen, it's, you lost your opportunity to provide security guidance, and when you find out after the fact, then it's once again that friction that I was referring to. And that time scale for how fast those changes are happening these days is incredible. So that's a problem that I want to talk about. So I talked about, just the sheer complexity that infrastructure as code brings and the challenges that this creates for security teams. So let's talk a little bit more about why this is happening and the kinds of ways that these architectures are evolving. So the first use case here is new business requirements. So you're in a regulated industry, a customer comes to you and says, hey, I'd like you to be compliant with this new standard. That's one example where business requirements change. Customers come to you and say, hey, I'd like to, you have this amazing data set, right? Can you show me what you can do by providing some analytics on that data? And a developer today, going back to 10 years ago, right? The developers that I worked with, right, if they wanted to deliver a machine learning capability as part of their application, it would take them roughly, 2 to 3 months to design, implement, ship. Today, for a proof of value, a developer that's familiar with these cloud capabilities can probably turn it around as early as 4 hours. So the speed at which development teams can operate and deliver on new business requirements has changed, and now they're more receptive to these customers and their customer requests, and they're able to deliver on them. Another example is new technology requirements. You might be working with a particular database technology and you want to use the cloud native capabilities that your cloud service provider offers, and you want to shift to these new capabilities. And these types of changes are also becoming easier and easier. And you see foundational changes happening to these application architectures as new technologies are added to your application architecture. Then new security requirements. I don't see as much of this, but I will say that this is where security can really impact these application architectures. And as the threat landscape changes for your organization, as the application architecture changes, so your business requirements changed where you weren't processing sensitive data, and all of a sudden now you are processing sensitive data. Fundamentally, that should lead to new security requirements that get applied to this application architecture that also can be reflected in this infrastructure as code. And so, there's kind of a couple different ways this happens. One is, security requirements are changing because the business use case has been altered in some way, or security requirements are changing because, you're recognizing that you're facing certain threats and you want to adopt different architectures that mitigate against those threats more effectively. And then the last way you'll see these architectures changing is really cloud features are constantly changing. So if you track the AWS APIs and you look at historically, over a calendar year, how many days where they haven't made an update to the AWS APIs, there's probably 3 or 4 days in the calendar year where updates don't happen to AWS APIs. The cloud service providers are moving at such an amazing pace, and they're constantly changing their feature capabilities. And part of this is they'll deliver capabilities that are actually half-baked, that don't have enough security capabilities baked in. And eventually, over time, they'll start adding those capabilities. And as a security architect, I'm faced with the problem of constantly keeping up to understand when changes are happening to these capabilities so that I can then provide the best guidance to my development teams. And that's been an incredible challenge. I'll give you an example of when Microsoft shipped the Microsoft SQL for Azure. Initially, it didn't support database encryption. And a year or two later, they added the capability. But you had to be plugged in, following all of the news from Azure to then realize that this happened, and then go back to your development teams and actually, impact these application architectures to then deliver on your database encryption requirements, for example. So I'll shift gears and talk about what we can do to actually address these trends. So a big focus of mine recently has been really how can we democratize security for developers? I see a couple challenges. So one is, with all this automation, as well as just recognizing that security teams from a resourcing standpoint are just outmatched. And the statistics from a survey several years ago are 100 developers to a single security resource. we as security professionals are really not well positioned to scale to the size of the problem. And so, when development teams have been able to accelerate through automation, I'll talk a little bit about that in the next slide, but really a key aspect of the solution here has to be involving the developers. And there's been a lot of talks here that have kind of touched on this, really making security easy for developers, giving them sufficient training from a security standpoint, investing in training, and really investing internally into the security practice so that the guidance that's being provided to those developers is applicable, accessible, and actionable. And I'll touch on this a little bit more later, but really, a consistent challenge that I see, and there was an example earlier, I think a few talks ago, right, where someone mentioned CSRF. And, there's a lot of developers that I've worked with, right, where security terminology is not really accessible to them. So how can we make it easier for them? How can we involve them in the process and help them understand, what they need to do, why they need to do it, and then, help them with the how. Like, how do you actually fix this? And the more guidance we can create that's accessible, right, the more likely it's going to get adopted and it's going to end up in the production environment. Another big thing that we need to focus on as security professionals is really invest in building security design patterns, reference architectures. It's really hard to scale to the size of this problem unless we have kind of our own catalog of best practices that we can go back to and provide to those developers. I see organizations that have kind of built these centralized, multifunctional teams that involve the developers, involve the DevOps teams, involve the architects and the security architects and other security professionals to really help build out design patterns. And they're building these patterns as Terraform code so that it's more accessible to the developer that's actually writing that Terraform code. So that SRE, that DevOps person, can rely on these templates and actually build off of these templates. And so, investing in really building the right design patterns for your organization, for your application use cases is really critical. And the way to make it developer friendly is, right, to present them as Terraform code. And once you build these patterns, you can then bake in your compliance needs. You can really look at coverage, like what are the key application use cases that I need to cover. Where this fails and where this becomes really challenging is it's a heavy investment to start with. If you don't already have a security design practice in your organization, then kind of starting a security design practice from scratch is a pretty big investment. It's resource intensive, it's skill set intensive. But if you have the resources to do this, then it makes sense to really prioritize the use cases that are most common and handle the less common use cases more on a case-by-case basis. Because the challenge with this approach is it's really hard to build one-size-fits-all solutions for every application use case. If you try to do that, right, you're going to go back to creating friction with those development teams because you're not going to be building things that are applicable to them. And in your organization, right, it's to succeed at this, the one thing I've seen, right, where organizations really do this well is where they have good partnerships with their development and architecture teams so that they can kind of work together and collaborate effectively to build this. And then I talked about automation, right? Really, this is absolutely critical to keep up with this trend. And if you're not seeing this trend, like, you will start seeing it in your organization as development teams embrace these technologies, and security has to respond by embracing automation, right? Leverage automation to fit right into those development workflows so that you get visibility into every change that's happening. Every time a change is made to that Terraform, that is a change to the application architecture that should be assessed from a security standpoint. And so the more automation you have to get that visibility so that when you need to kind of get engaged and look at a particular application architecture, that's going to be incredibly important. And I don't know of a single security team, including mine, that isn't resource constrained. And so automation is really the only way to scale resource-constrained security teams and get the most out of the resources that are on your team. Any questions? So a key part of adopting automation is, I talked about, democratizing security. It's really, you want to make security easy for developers, and the best way to do this is fit into their workflows, right? Security needs to be at the table as changes are made to code. Modern security practices need to be fully integrated into that software development lifecycle, so that as early as the design of that application, right, when the concept is being talked about, Chris talked about this, right? Like, you want to be at the table. You want to be threat modeling that concept. You want to be thinking about security for that concept. But then as that shifts towards code and we all know that, the design continues to change, and the most accurate representation of that design is going to be that Terraform code or that CloudFormation code. And so being plugged in there so that you have the ability to really impact the design as it's being developed is really important. And then managing drift. So it's good that you were able to engage early, you were able to provide good security guidance. But how do you make sure that what got deployed remains secure and compliant by design? And how do you manage drift so that someone didn't go in through the cloud console and make a change to that application architecture that exposed your S3 bucket, as an example, the most kind of common use case that everyone talks about. How do you get visibility into that? And how do you make sure that that infrastructure as code really remains the source of truth for what that deployed application architecture is? And the interesting opportunity that infrastructure as code provides for us security professionals is that it lets us automate the how. So maybe just going on a quick tangent, right? Like, if you look at that Terraform code, it tells you what are all the components in this application architecture, how do those components interact, and as a security professional, what is the access control policy that's governing the interaction between these two components? What's the network security policy? How is data being protected at rest, in transit? What are the CORS rules defined on this load balancer, as an example? Like, all of this is entirely codified in Terraform. So if we as security professionals, right, become more proficient with these languages, we can help automate the how, because now what we can do is actually provide very specific direct guidance in these codified ways so that you can impact that application architecture and fundamentally transform it to be more secure and compliant. And then finally, right, it's absolutely critical to create good feedback loops so that you have good post-deployment monitoring in place. You are looking at changes that are being made, potential risks that may be introduced, and then continuous pen testing, continuous risk assessments, and really getting feedback from these developers so that we continue to improve the guidance. We continue to provide more, going back to accessible, applicable, and actionable guidance. So I'm going to do a quick demo, but I'd love to open it up to questions, thoughts.
How do you go back to managing drift? I mean, do you have any ideas? Because if the infrastructure is code, right, then any changes to that infrastructure should have alerting or some sort of assigning that code, right?
Yeah. So the one good thing is, right, we kind of know how to solve the problem from an application code standpoint, right? And we want to apply the same best practices here, where any code changes should require two-person reviews, for example, right? So all of those best practices I absolutely apply here. I think drift management is a little bit more challenging with infrastructure as code because you have so many different channels to actually impact that application architecture. And the simplest approach and the most effective approach is actually to not allow any other channels, right? You can configure your cloud to not allow changes over the cloud console, not allow changes over the CLI, and only allow changes through the pipeline. And the pipeline then becomes kind of the place where you invest all of your governance and audit capabilities into. And now you see all the changes that are happening. That is the most effective approach. Doesn't always work because, we as security professionals aren't often in the loop and don't quite understand all of the different channels and avenues that are open. And if we are not able to, configure the cloud in the right ways, and developers need this access because, let's say, there is an incident of some sort, like an availability incident, system went down, and they need to fix things. They might not want to go through the pipeline. They might want to just go straight to that resource and, restart whatever it is that they want to do. And so they need certain types of access. So there are challenges, right? If you lock down the cloud access, then you have to invest in, kind of break glass accounts and being able to give those developers access. So if you have good identity lifecycle management tools, then this is a really viable approach, because then you can give them just-in-time access when there is an incident. But if you don't have those tools, you're going to leave that open, and then I'll talk about how automation can help that, right? Because if you have automation that plugs into your pipeline as well as is monitoring your cloud, then it can measure drift, right? And that's kind of the problem that we try to solve, right? Is can we actually show you that what is deployed is actually what that code says? And if there's any drift between, alert the security team, right, and create changes through the pipeline so that that drift gets remediated right back through the pipeline. And once again, your audit and governance tools are then tracking those changes. They have visibility into those changes, and can give you that instant visibility as changes are being made. Yeah. All right. Jump to a quick demo. I did pray to the demo gods, but I was mucking around with my demo all the way until the last minute because I wanted to. That's not going to work well. All right, I'll do my best. All right, so I have an empty Git repo right now, with the exception of some hidden files from my Visual Studio Code. What I'm going to do, I'll just kind of show you what I've done here. So there's a lot of tools, right, that integrate into pipelines. I'm just going to show ours, but like if you guys look at Bridgecrew or Chekhov, there's TerraScan, TerraGrunt. There's a number of these tools that focus on misconfiguration checking. And then there's kind of tools like ours that kind of focus on the architecture, but they all have this ability to really integrate into your pipeline and give you that visibility that I was talking about. So I've set up a GitHub Action. Are you guys familiar with, is everyone familiar with GitHub Actions, or have you guys heard the term? It's GitHub's way of kind of integrating into the pipeline, and it's an action that gets taken, right, based on certain conditions. So in this case, right, this is part of the CI pipeline, and it's going to run a job here, and I've configured it to run a job against our platform, essentially. And the window isn't complete here, but if there's an app marketplace where I could just search for it and it'll automatically add the job to this pipeline, and then I just have to configure the secrets. So I've done that already. So that's the part that's pre-baked, not where I want to go. Give me a second. Is there a reason why that's not? All right, we're gonna shift gears and just mirror the display. Much easier. All right. So I added a Terraform example to this project. Essentially, all it is an architecture like this. I simplified it for the purposes of the diagram, but it's deploying a VPC. It's got, great. All right. It's got an API gateway in AWS. That triggers a Lambda. The Lambda then, puts something in the S3 bucket, and the API gateway is configured to log to the logging bucket. There's a backup of the S3 bucket, and then there's a KMS that's issuing the key for encryption for the S3 bucket. So straightforward example, probably, closer to maybe a couple thousand lines of code, I would guess. I didn't do a check, but I'm going to go ahead and push this to this GitHub project, and let me go back to where we were. No, not there. Actions. All right, so my merge just happened 11 seconds ago. It's queued, our platform is queued, and it's going to run on it. But essentially, right, like this is the type of integration that I'm talking about that kind of fits into that developer workflow so that as they're making changes, right, immediately you are using automation to scan that code to understand the application architecture and then understand where the potential gaps are. This takes a bit because we are actually building out a model of that entire application architecture. And so let's just refresh to make sure. All right, looks like it's queued. But the one thing about GitHub Actions is it doesn't give you a lot of visibility into where things are. All right. So it looks like it's running. There it is. So it ran, it checked this project, and I'll go back to the project. I should have spent a little bit of time just explaining what we did here. So I have an API gateway. It's just deploying an API gateway resource with some proxy APIs and then connects it to the Lambda. I have the Lambda function that's really not doing much, but it's defined to kind of connect to that S3 bucket, and it has some permissions defined. I have the S3 buckets, and so this is kind of the main S3 bucket, and then there's S3 buckets defined for logging as well as for the backup. So let's see. So like you'll see, this is the inventory bucket. That's yet another bucket that I didn't have in my diagram. What else is going on here? Yeah, and then it's subscribed to an SNS topic, but there actually isn't an SNS service in here. So, all right. So let me kind of show you what that looks like then. So projects. It's this one. All right. Oh, this isn't showing up right. Doesn't like the tiny display. All right, still not showing up right. Let's try this again. Yeah, got some scaling issue with the UI. But I wonder if I can change the display parameters. All right. It's not as readable, but hopefully, the main point that I wanted to make here is just that we scanned this code, right, and like instantly we were able to identify issues with it. But now if I go back to this project, and what I'm going to do is I'm going to add a resource to this. And so I will add a This is for the sake of the example. I'm just going to add a Kinesis resource. So this is AWS's machine learning service. All right. And then let's add an SQS topic. So this is their message queue. Let's add SMS instead. Okay. And it's much harder to map. All right, so I made a change, and what should happen is, through automation, we should be able to pick up these changes. And that's kind of that first use case that we were talking about. And I'll shift over. So let's go back to the actions. It's running another job. And this is just an example of how quickly changes can happen to that Terraform. And I'll go back to the Terraform while this is running, so the job finished. But all I did is I added from a stock example a Kinesis service. It's not integrated to anything. It's not connected to anything. But if I wanted to connect it, right, I would define the right parameters, and I could easily connect it. And you'll find that most developers that aren't familiar with Terraform, the first thing they do is they'll either go to Terraform's repo. So Terraform has like modules defined for all these things. You can just go pick on one of these modules, or they'll go to GitHub. Say, let me just find an example of someone who's implemented this machine learning service, and they'll add it to their project, tailor it a little bit, and get it working, and ship it. And we kind of routinely scan these GitHub repos, right? Like especially the public ones. And most GitHub examples, or most people that are publishing examples, right? They're trying to show the functional capabilities of that service. They're not interested in making sure that it's securely integrated into your project. They don't understand your use case. They don't understand whether it deals with business sensitive data or not. And so fundamentally, as you build off these examples, and this is kind of what I did, you're going to find issues, and like other platforms, ours will as well. And so now if I So let's search for Kinesis. I hasn't updated. This is really hard running the mouse from here and looking at the screen over there. Try this one more time. All right. So, we're identifying the fact that this Kinesis service doesn't have it has a key defined for encryption, but it doesn't have a good key management plan. And so like things that are associated with the key management plan, inventorying that key, making sure the key has a name, it's tagged appropriately. And kind of providing that developer with, so this, this is kind of the what, right? Like what is the issue? Why is this an issue, right? So if you don't manage keys properly, then data and transactions that they protect can be at risk, giving them a little bit of an understanding of why is this an issue, and the more specific how, right? Like what do you need to change? So like these specific configurations, right? Go change these to this value, or set these appropriately, right? Giving them the actionable guidance that they need to actually go quickly fix this, and save them time and help them, continue to deliver at the velocity that they want. So that's kind of that one use case. Another use case, right, is, and we kind of do this in our platform where if I were to go select that Kinesis service, I'll just take the stream, right? Let's say I want to change its business context. And I want to say, you know what, the business use case has changed. Now it's dealing with business sensitive data. And so we're going to say the data sensitivity has changed for this application. What you can do through automation is now when your business use case changes, you can change the security requirements that you're applying to this service. And maybe data at rest encryption wasn't as important for you because it wasn't dealing with sensitive data, and now it is. And what should happen is we'll flag additional gaps, and then we will provide more actionable guidance. But the big thing that we can do with these types of approaches is as you start building a proof of value, security can be engaged, and security can be designed to be appropriate for that proof of value. That proof of value may not be dealing with sensitive data. It's really only for internal consumption. And so we can design security for that proof of value. As that proof of value turns into an alpha product, for example, and it is dealing with some sensitive data, right? We can appropriately evolve the security architecture as the application architecture is evolving. And then when that alpha product then goes to beta and now is clearly dealing with sensitive data, right? Your architecture can evolve alongside of it. And that's fundamentally what, the opportunity that infrastructure as code is presenting us, right? It's presenting us this opportunity to really stay in sync with development, to help evolve security as the application architecture is evolving. But, kind of the key aspects of the challenges of keeping up with the scale of the problem and just the rate of change that's happening, right, requires one, involving the developers and having, really strong partnerships there, making sure that the development team is appropriately trained from a security standpoint so that as they're making independent decisions around security, they're making good decisions. But then also, having automation so that you have visibility. You can define these guardrails. You can make sure that as, developers have the freedom to make the choices that they want in the architecture, but at the same time, they stay within the guardrails that you've defined, and as soon as they deviate, right, you have the visibility to jump in and then provide additional guidance. And that's really the, only viable approach that I see to keeping up with just the velocity and the rate of change that this is bringing. So that's all I had. I'd love to open it up to questions. I put you all to sleep. Oh, yes.
So basically, from the tool perspective, is your company provide a tool to scan the infrastructure as code, for example?
Yeah. So
the Terraform.
Yeah. So we have a solution in the space, but there are other open source tools as well. Okay. And so yeah, I'm happy to talk to you about our solution, but I think the main point that I was trying to make is, there are tools that you can integrate into your pipeline, and there is automation available to you to really get that visibility that you sorely need, so that as your development teams, really embrace these types of technologies, you're getting visibility into the changes they're making.
Is your tool open source?
It's not.
It's a commercial.
It is commercial, but I'm happy to talk about it, you know, after. Yeah, yeah, yeah. We can. I'll catch you up after the talk. I'm happy to talk. Yeah.
So, we also at our place, we have like a lot of Ansible stuff. I know there's some differences between Ansible and Terraform and some of the other ones, but do y'all's tool, like, does it work with Ansible at all? Is there any integration there, or is it, am I asking the wrong question?
Yeah, I mean, no, it's a great question. We get this question from customers a lot. Like, I mean, for us personally, right, that's on our roadmap. I think what in Ansible, Chef, Puppet, Salt, right, they were kind of the first generation of infrastructure as code solutions. But you know what I think has changed, and they're moving in the same direction, right? They're in the space as well. They all recognize this. They're like, from what I see at least, right, my vantage point, they're moving in the same direction. But fundamentally, what has changed is compared to, you know, the Chef recipes and the Ansible scripts, right? What has changed is with Terraform, Pulumi, for example, lets you build infrastructure as code in the language of your choice. So you want to write infrastructure as code in Python, you can write it in Python. TypeScript, great, go for it, right? And so what has changed is you can build infrastructure as code. It's less scripting and more closer to software development, where you can build these kind of modular, you know, architectures, modular files. Everything is version controlled, and that is where I feel like things have really shifted from the days of Ansible, Salt, Puppet, and Chef. It's just that now what you're seeing is all of this is just fairly mature code. Like Terraform has, you know, modules, functions, you have variables, you have, you know, you can build nested. Oftentimes when you know, when I look at Terraform and I can tell whether it was an SRE or a, you know, infrastructure person that kind of came into the industry and became an SRE, or it was a developer that started writing Terraform, because developers will write nested functions, right? Good coding practices, but incredibly hard to parse, by the way, in an automated way. And like, you know, there's just layers and layers of nesting, and then you got to keep traversing function calls before you figure out what is this actually doing, right? And infrastructure folks, right, are more closer to scripting, and so you'll just see, you know, exactly what they're trying to do right up front. So just random comment, but there is a question here. No? Oh. Awesome. Anything else? All right, well, thanks for listening.